Okay, welcome America, welcome Taylor Swift. Today we are going to be reviewing converting radians to degrees and degrees to radians. So, and we'll see how far we get if we can do reference angles. So we'll go ahead and start. So the concept behind this is we know a circle is 180 degrees, or 360 degrees. Sorry, I don't know what I'm doing. A straight line is 180. Everyone's laughing at me. I just want to document America. Everyone's laughing at me. So this is 360 degrees, right? It's also equal to 2 pi radians. So half of the circle is equal to 180 degrees, or pi radians. So if I have an angle that's in degrees and I need to convert it to radians, since pi radians is equal to 180 degrees, I can use that as my special one to convert degrees to radians or radians to degrees. And this is how it looks. So right now my unit is degrees and I need to get it to radians. So I'm going to multiply that by something that's equal to 1, which is pi over 180. Now the reason I put pi over 180 degrees is because now I have, this is like 200 degrees over 1. I have degrees in the numerator and I have degrees in the denominator, and they will cancel. And I will have radians when I multiply straight across as my answer, which is what I'm looking for. So the easiest thing to do, and I don't know why they don't teach this in middle school anymore, is to simplify first before we multiply across. Whenever you're multiplying fractions, it's the easiest thing to do. So right now I can cross off a 0 out of each of those, right? So this is 20 over 18. Andrew? Hi. Okay, so now what's the largest number that goes into 20 and also 18? What's the factor? What's the largest factor of 20 and 18? What's the greatest common factor of 20 and 18? 2. Anything larger than 2 that goes into 20 and 18?
4.
4 times 5 is 20. 4 times what is 18? 2 it is. Let's try 2. Okay, so I'm going to use a different color. I'll use this orange, okay? 2 goes into 20 10 times. 2 goes into 18 9 times. So I'm going to multiply the numerators across. 10 pi. And the denominator is 1 times 9, 9. Much easier to, much easier to simplify first than multiply across. If you don't simplify first, then you end up with a bunch of large numbers that you have to simplify at the end. This one isn't too large, but I'm just trying to get you to understand the concept. That's it. What's the next problem I wanted to do? I wanted to do number 2, because there's a negative. Can I erase that?
Yeah.
Okay. So I'm going from degrees to radians, so I'm going to multiply by pi over 180. Can I simplify first? Let me just first divide by 10. So now I've got a 15 and 18. We know the answer. We're gonna have a negative in our answer, right? What number goes into 15 and also 18? What's the greatest common factor of 15 and 18? 3. 3 goes into 15 5 times. 3 goes into 18 6 times. 3 times 6 is 18. So multiplying across, we have negative 5 pi, negative 5 pi, and the denominator is 1 times 6, 6. And now we've changed our degrees to radians. How are we doing? It's so not hard. It's so not hard. Now, in reverse, what's the next problem I wanted to do? Number 10. Can I erase that?
Yeah.
What just happened? Things are happening. That's not it. Did I back out of it? Maybe I did. Okay. and I can attach this worksheet. What number? 10. This one is in radians, and we need to change it to degrees. So instead of multiplying by pi over 180, we're going to multiply by 180 over pi. That way, we'll have degrees in our numerator. The pi's will cancel, our radians will, and our answer will be in degrees. So right now I can tell this pi is going to cancel in the numerator, this pi is in the denominator, those are going to cancel. And then is there a greatest common factor of 6 and 180? Is there any number that goes into 6 and also 180?
6.
Okay, how many times does 6 go into 180?
30.
6 goes into 6 once, 6 goes into 18 3 times, add a 0. Now I can just multiply across. Are you with me so far? With the 30 and the simplifying, basically. Okay, so now this is 7 times 30. 3 times 7 is 21, so it's 210. And then 1 times 1, which is 1, that's degrees. That's it. It is pretty simple. You just have to remember if you're multiplying by 180 over pi or pi over 180. And you want the original unit to cancel. So if it's degrees in the original unit, that's in the numerator, you need to have degrees in the denominator when you're multiplying by, so they cancel. Does that make sense? All right. So let's do, since we're only at 6 minutes, let's go ahead and sketch this angle for number 14. Yeah, let's do 14. In standard position, then find its reference angle. So 120 degrees. So this is how you do this. We know that halfway around the circle is 180. We know this is 90 degrees. 120 is 90 plus 30 degrees. So it's going to be right around here. So there's your angle. So there's your terminal side of your angle. So there's 120 degrees. So now we've sketched it in standard position. Now we find its reference angle. A reference angle is really how far away the terminal side of that angle is to the x-axis. Okay, so if the angle is right here in the second quadrant, what is this distance? And it's always going to be positive. 60 degrees. There we go. The reference angle is 60 degrees. Now let me give you a quick summary, okay? If you get an angle that's, I don't know, let's say it's 270 down here, okay? You can have reference angle up to 90 degrees. So you can think that would be 90 degrees. Let's say the reference angle ended in the third quadrant, somewhere down here, okay? The reference angle would be this distance. Let's say the reference angle, or sorry, the terminal side of your angle was here. The reference angle would be this distance. It's the closest distance, it's within 90 degrees from the x-axis, and it's always going to be positive. I think that's all I wanted to say about reference angles. It says do not convert, so if you get a problem that's in degrees, you want your answer to be in degrees, and if you get a problem that's in radians, you want it to be in radians. And I think that is it for those. We're going to do some more problems in class, but my video is over.